Hello world. Today we will rotate a matrix. We are provided 3 by 3 matrix here, which is two-dimensional array of numbers arranged in rows and columns. Each element in the matrix is identified by its row and column index. And we are asked to rotate it by 90 degrees clockwise in a place. We must keep it in mind. As we see here, the length of matrix is 3. Let's count 1, 2, 3. If we remove one of these columns, we are left with 2 columns. Now let's access the element at index 0 in matrix list and see the length of it. As we see, it is 3. If we remove 2 of these elements, then we are left with 1 element. If we remove one of these elements, then we are left with 2 elements. Now let's access the element at index 1 in the matrix list, and we remove one of these elements, then we are left with 2 elements. We need the element at index 0 in the matrix in order to determine its dimension, assuming that the matrix is square. The variable n represents the dimension of the square matrix. It may be confusing, so let me explain it with different words. If matrix is a square matrix, all rows must have the same number of elements. The length of matrix 0 here gives the number of elements in the first row. Therefore, n is assigned the length of the first row and represents the number of rows and columns in the square matrix. By using n as the dimension, the code can correctly iterate over the rows and columns of the matrix, assuming that it is a square, the matrix is square. If the matrix were not square, meaning it had a different number of rows and columns, this approach would not work for rotating the matrix. In the next step, we'll loop over rows and nested loop over columns. First, we need the outer loop. It iterates over the row indices of the matrix, ranging from 0 to n. Then the variable row takes on each of these values in turn. Secondly, we need the inner loop. It iterates over the column indices of the matrix, ranging from the current value of row to the variable call takes on each of these values in turn. Let's print and see what this row returns. As we see, it returned row indices of the matrix, and we may print and see what this call returns. Now we see the column indices of the matrix. Then, inside the second loop, the elements at the row call and call row positions are swapped. This operation effectively transposes the matrix. As a result, we see the values are swapped. But it's not the expected result yet. The expected result is this. As we see here, we need to reverse the order of elements in the list. In this case, row of the matrix in place. We see the first expected result is here 7, 4, 1, not 1, 4, 7. And the second expected result is 8, 5, 2. Also, third expected list is 9, 6, 3. So we must achieve this. So now, after this transposition is complete, reverse elements in each row using the reverse function or method. In order to do this, we need loop. We loop through the length of the dimensions of the square matrix. It means we're going to iterate over each row index of the matrix, and then for each row indexed by I, the reverse method is called. Let's call it. This reverse method reverses the order of elements in the list. In this case, it reverses the the row of the matrix in place. Now we see the printed result is the same as the expected result. Finally, we can comment out this line of code because we are not asked to return the results, the LeetCode task, but we ask it to return the matrix in place. Yeah, hey, we solved the problem. Congratulations.